Hi everyone, I'm Tammy Butow and today I'm here to talk to you about chaos engineering for CICD. So let's get started. So let's start off with something simple. What is CICD? Well, it starts from continuous integration, writing code to creating an artifact, then moves to continuous delivery, which involves taking that artifact and moving it to production. So continuous integration to continuous delivery, code to artifact, artifact to production. So let's talk a little bit more about continuous integration to start off. Here we've got lots of engineers writing code, committing it to a code repository, then we build our application, we get our artifact ready, and then we have an artifact repository. Continuous delivery is where we take that artifact and we move it through all the way into production. So you might need to do things like access cloud infrastructure, provision new infrastructure to be able to deploy it, get through different types of change management. This really depends on where you work, how many levels of change management are required. Like for example, I used to work at the National Australia Bank, and obviously in finance, there's a lot more change management procedures that you need to go through compared to like a very small startup, which actually might have no change management. Or very small amount of change management. Maybe one person just has to approve it. You also would need to go through security. If you have a security team, security engineering team, so they would need to usually approve that, make sure that's all good to go, especially if it's a big change. Often the security team would want to be able to be involved. This is what I've always found when I've worked in large enterprise companies. Very good to have a friend in security. Next up, we've got different types of release strategies. So this could be, for example, blue-green or red-black, or canary, where you just put out a small bit, a feature that you want to test to a small number of users, sending it out there, see how it goes. If it doesn't work, you can just pull it back, but you're not pushing it out to everyone. The next step is verify reliability of your change, the durability, making sure you don't lose data, and the performance. So you want to make sure that you're not seeing big performance regressions. This is why it's really important to do good monitoring and make sure that you have some baseline metrics and you're always comparing back. Then lastly, rollback if required. In large enterprises, they're pretty awesome at rolling back. They only ever write code in a way that you can actually roll it back because they know that it's critical to be able to roll back at any moment. So yeah, like when I worked in enterprises, I saw that all the time. You were told, like, write your code so that you could roll it back at any moment and everything would be fine. Don't make it be, hard coded to all these different dependencies and make it really bad. So when you roll it out, it's impossible to roll it back. You should always be able to roll it back. And that's a very different mindset. Building services and writing code, writing applications in a way that you can roll them back is pretty different. But I reckon it's an awesome thing. It's much harder to roll forward or fix live in production usually than it is to just roll back. If you've got a problem, you can just go, let's roll back, fix, done. Takes hardly any time at all. Fixing live in production, well, that can be really dangerous. Something that I don't really like as a site reliability engineer at all, especially because if you're fixing something live in production, you still need to go through tests. You shouldn't just think, oh, I'm exempt from testing because I'm in production and there's already a problem. So I wanted to tell a little bit of a story about something called Green Guardian. So Green Guardian is actually from a Pokemon episode. And it's basically a little character that goes along and saves this giant rainforest that's, burning down and it's in danger. And so when I was working at Dropbox as a site reliability engineering manager, actually part of my role was to work on the dev tools team. When I'd been there for a while, I first started leading databases, then block storage, and then I also worked on dev tools in a team called Code Workflow. And I was helping out the build team and I was on call for the build team. And so the build team has an on-call rotation called Green Guardian, because they're responsible for keeping the build green. And I actually think this is an awesome idea for a rotation. It's actually everyone's responsibility across the company to keep the build green. So it was cool because it was like a rotation actually that I thought should have people from different teams that are on there so they actually can feel it. They have skin in the game. They understand what's happening. They understand why the build is sometimes not green. Because a lot of the time, you know, when people are talking about getting their code into production and, you know, there's some problems with the build or the build's not working or there are issues, they don't understand all of the different things that can go wrong that mean that you don't have a green build. So having a Green Guardian rotation is an awesome way to learn and to feel the pain and have more empathy for other folks. And make sure that, you know, as a company, you're all heading in the right direction together. You're all making things better together. And the other thing too is you should definitely be collecting metrics on this on-call rotation. You know, it's an interesting on-call rotation, right? Because you're supporting developers internally with build and build tools, any issues with the build, making sure that people can keep shipping code. So, you know, say for example, if you have 100 engineers at your company, then you're supporting 100 engineers, usually within business hours, Monday to Friday. So it's not like a I'm getting paged at 2 a.m. sort of situation. Shouldn't be, especially if you have rollback in place, because you can just roll back problems that happen at 2 a.m. instead of having to push forward new code. Here you can see what I talked about before. This is why rolling back is very good at 2 a.m. compared to rolling forward. I don't like that at all. But if you do have this on-call rotation, then you can collect some baseline metrics and say, okay, well, 5 days a week, we have a Green Guardian build on-call rotation responsible for keeping the build green. And basically, we end up getting paged, escalated to, have our systems page us automatically this many times a day, 10 times a day, 5 times a day. You should actually measure how long it takes you to resolve those issues. Is it 5 minutes? Is it hours? Is sometimes your build tools, are they not even working for several hours? It can be really bad at some companies that I've worked at. I've definitely seen that in the past, and I've heard tons of stories about build infrastructure, build pipelines, like tools not working. And it's important because if you can't do anything, you can't get any new features out to customers, if you can't, you know, build any new products, if you can't really do anything, then what are you doing? So what do we want from CI/CD? The first thing I think we want is increased developer velocity. So we want to improve our ability to plan, build, test, and release applications to customers quickly and at scale. The next thing I think we want to do is what this happy bouncing octopus is doing in the middle, is improve the developer experience. We want to make it fast and easy to ship working code to production. We just want to make developers feel happy. You can actually find this out by sending out a developer happiness survey. I've done this in the past and I definitely recommend it. And the other thing that we want to do is we want to identify customer impacting issues early before they actually hit the customer. So it's just like way cheaper if we identify them up front before they're in production. It's easier to fix them when they're identified earlier on. So, you know, as a site reliability engineer, someone who spends most of my time in production, but I've also spent time, you know, working on build tools and workflows and staging, you know, pre-prod, different environments to try and make them better. But I would definitely say it's always cheaper to fix problems before they hit customers and impact customers if possible. So it's good to try. So how can we do it? Well, here comes chaos engineering. Chaos engineering, thoughtful, planned experiments designed to reveal the weaknesses in our systems. You inject something harmful in order to build an immunity. There are many places that you can practice chaos engineering. You can see here in this GIF, test, release, deploy, operate, and monitor. These are definitely some areas where you can do some interesting things. So for example, we can run individual experiments, CI/CD pipeline experiments, game days and fire drills. We can do scheduled experiments, lots of things we can do. So now let's actually do a deep dive into a demo of Spinnaker plus Gremlin. Spinnaker is a platform for you to be able to do continuous deployment, and it was built by Netflix. Then we at Gremlin, that's where I work, we actually did a project where we worked with the Spinnaker team, and Spinnaker is open source. You can find it on GitHub. Quite a few companies out there actually use it for their continuous deployment, and Netflix uses it. So what we wanted to do was we wanted to allow you to run chaos engineering experiments as part of your CI/CD pipeline. So you'd be automatically running them as needed. So let's just first start off by talking about Spinnaker and how it works. Well, Spinnaker has the concept of pipelines. The pipeline is the key deployment management construct in Spinnaker. It consists of a sequence of actions known as stages, and you can pass parameters from stage to stage along the pipeline. You can start a pipeline manually, or much better is that you can do it in a way that is automated. So you can configure Spinnaker to start a pipeline automatically, triggered by an event, like a Jenkins job, for example. Jenkins is quite popular, completing, or a new Docker image appearing in your registry, or maybe a cron schedule, or a stage in another pipeline. So here's a diagram here. The Netflix team often uses canaries, where you're pushing out a change to a small number of users, seeing how that goes. So what we have here is we start, we find the image from test, we deploy the canary, then we get to the stage where we cut over the manual approval, wait 30 minutes. We deploy prod, so red, black, blue, green. We then tear down the canary, we wait 2 hours, and we destroy old prod. So this is just a diagram of red, black, or blue, green. You can see here that we have 2 production environments. One is the blue on the diagram, one is the green. And we can actually cut over and say, let's show everyone green now, using the load balancer. Or we can say, well, now let's show everyone blue, because that has the newest changes. So that's how you do that type of a deployment. Here's a really nice diagram that I like, actually from Martin Fowler. So he has, like, you know, the user, the router, then we've got the web server, the app server, and the database. And there's the green versions and there's a blue version. And you switch and show like one of those, either the green or the blue, based on what you want to do at that time. So for Canary, what we do is we have primarily everyone in this example on blue, except we have a few users already on green because they're trying out a new feature that is only on green. So it's like maybe there's a new widget, or maybe there's a new navigation, and you only want some people to try it out, but not everyone. This is how you can canary something and try it out, test it to make sure that everything's going well before you push it out to everybody. Another cool thing to do here is, you know, think about metrics, like metrics that you want to measure while you're canarying something. If, for example, you push your change out to a certain geographic location, you can get some really interesting metrics based on that location for performance, latency. You can do some chaos engineering experiments specifically for that as well. So you can do some latency injection, you can do some packet loss injection, lots of cool stuff. So now let's dig into the demo. Okay, so we've got Spinnaker up and running. There's actually a tutorial that you can use to follow along and do this yourself if you search Gremlin's Spinnaker. And Gremlin's free to use for our smaller version of the plan. So you can definitely go there and try it out. If you go to gremlin.com/buttons, that's my nickname. So what we're doing here is we're clicking actions on the right, and we're clicking to create a new application. So Gremlin test at example.com, GitHub, description for testing Gremlin. We'll leave the instance port as 80. Now, this is a screen that we get to. No server groups found in this application. Totally fine. This is the success screen. Now what we want to do is we click on pipelines because we're going to configure a new pipeline. What we want to do here is we want to actually get started doing this. We'll go to this first screen, the configuration screen, and we want to start filling it in. So we'll select here Gremlin from the drop-down list. You can see there it says Gremlin runs a chaos engineering experiment. And then what we want to do is we want to grab our API key from Gremlin. So you should already have a Gremlin account, going to gremlin.com/buttons. If you go to company settings, you'll be able to get your API key. Copy that. Now take it back over, and in the gremlin stage that you created in Spinnaker, you add the API key. So here we can see that it actually will fetch the information from Gremlin. So we've got our target template is our Ubuntu host. The attack type that we want to run for this example is CPU, could be shutdown or it could be black hole. Those are the types of attacks that you get with Gremlin free. There are other types of attacks up to 12 for our full product, but black hole will give you a good example for some sort of dependency issue and networking issue. CPU is good for your resource types of attacks, and then shutdown is good state attack. So now we're going to manually start this, and then it succeeded. So we can go back and we can look at Gremlin to check that that all worked well. Yep, totally worked well. CPU successful. So the last thing I wanted to say is you can join the Chaos Engineering Slack. You know, it's a great place to meet other people who are doing chaos engineering. You can ask and answer questions. You can make connections. It's awesome. Thank you so much. My name's Tammy Butow, and I'll see you on Twitter at tammybutow.com. Thank you for having me, DevOps.